Network address translation is the cornerstone of modern routing, enabling seamless communication between private networks and the public internet. Private IP addresses like 192.168.1.50 are non-routable over the public internet, requiring an NAT gateway to bridge the gap. NAT substitutes non-routable internal IP addresses with valid public addresses, solving IPv4 exhaustion and masking internal topology. In source NAT, an outbound connection originates from an internal client targeting an external server. The NAT gateway intercepts the packet, replacing the internal private source IP with its own public WAN IP. The web server responds to the gateway's public address, unaware of the client's actual private IP. Finally, the router checks its session table, translates the destination back to 192.168.1.50, and completes the round trip. Under port address translation, or PAT, the router uses unique ephemeral source ports to map thousands of internal hosts to a single public IP address. Each active connection maintains a state entry in memory. When traffic returns, the lookup table guarantees accurate packet routing. Destination NAT is used when external users need to reach internal servers hosted behind a single public IP, commonly known as port forwarding. The edge firewall intercepts the packet and rewrites the destination IP from the public address to internal server 10.0.0.5. When the internal server replies, the firewall transforms the source IP back to the public address before sending it to the client. In summary, SNAT changes the source IP for outbound traffic, while DNAT changes the destination IP for inbound service hosting. Understanding NAT state mechanics is essential for network design, firewall rule creation, and troubleshooting enterprise connectivity.